Welcome to today's lesson on tracing human evolution through natural selection. We will be exploring how genetic traits in early humans were shaped by their environment. Using a simulation to bring this concept to life, we'll also connect these ideas to how humans spread across different regions after migrating from Africa. By the end of this lesson, you'll be able to understand how genetic traits played a role in human evolution, explain the process of natural selection and how it shaped these traits, and lastly, explore how environmental pressures like climate and predators influenced early human population. We'll achieve this through an interactive simulation that brings these ideas to life. Well, natural selection is one of the key mechanisms of evolution. It's the process where organisms with traits better suited to their environment survive and reproduce, passing those traits to their offspring, to their offsprings. For early humans, this means that as they moved out of Africa and faced different climates, food sources, and predators, traits that helped them survive in those environments were passed on to the future generations. To better understand the impact of natural selection on genetic traits, we'll use the PHET natural selection simulation. In this simulation, you'll control variables like food availability, predators, and mutations to see how traits like fur color or speed affects the survival of rabbits population. While the simulation focuses on rabbits, the principle apply to early humans population as well. Different traits helped our ancestors survive depending on their environment, similar to how some rabbits might survive better depending on their fur color or speed. Now, access that link on the PowerPoint presentation. I'll also paste it on the chats or wherever it is easily available. You access that link, then it takes you to a Chrome page whereby you will reach this stage. Well, this is where the rabbit evolution or natural selection will take place. Now, working through the simulation together, once you are in, we'll start by setting up initial conditions. A normal food supply, one predator, and no mutations. Now we have food supply, the food is not limited. Then we add a mate, then we run the simulation. As you can see, we have just added a mate, and then as generation goes on, we are moving on to the generation 2, and the number of rabbits have increased on the environment because food is abundant. And then from there, as you can see on the graph there, the graph is increasing. Now we want to introduce environmental pressures. We are going to introduce the predators. There they are. They have decreased the number of population, and then as you can see on the graph there, the number of population of rabbits goes up and then down, and then it goes up again and then down. Now we are only left with two rabbits. They've reproduced again. We are left with just one rabbit, one white rabbit. And eventually, when the predators come, what happens? All of the bunnies have died. But I want us to include both white and brown fur. Then we start over. We add a mate. Now we have two genetic traits, rabbits with white fur and rabbits with brown fur. Now let's see how this take place. Now there they are, the rabbits with brown fur as well. They are coexisting now. Since we have reached a number of rabbits, then we introduce the predators. Let's see which kind of rabbits will be left after after the simulation has run. Generation 6. What do you think happens to the white fur rabbits? They are disappearing. We are getting less and less number of white fur rabbits and greater number of brown fur rabbits. Now we can only see a limited number of white fur rabbits, and then they have taken over the world, both brown and white, but the ones that were mainly there is white fur rabbits. Now this PHET simulation has variables. These variables, as you can see here, the first variable determines whether we are in a hot environment or a cold environment. And then the other variable, it says that you should add a mate. And when you add a mate, they start reproducing and becoming more and more and more. And then the other one is that when we add a mutation, we either uh, emphasize which fur is going to be dominant, whether the brown fur or the white fur. Then, as you can see here on the environmental factors, we have wolves and then we have limited food. Wolves are the predators that will eat the rabbit, and then limited food is the food that is found on the environment. Then here is where you manipulate your graph, whether you want the total number of rabbits to be shown, or you just want the white fur or the brown fur number of rabbits to be shown. Now, as you can see on the next slide, there's a graph there. This graph only shows the total number of rabbits that are being displayed on the screen. And then see how genetic traits like fur color affect survival. I think we have gone through the running of the simulation as well. We are approaching the end of our presentation. Well, we have seen that both genetic variation and natural selection played crucial role in shaping early human population. As early humans migrated out of Africa, they faced new environmental pressures that selected for traits like endurance, resistance to disease, or adaptations to different climates. The Out of Africa hypothesis provides a framework for understanding how these pressures led to the diversity we see in human population